about the satellite system, subsystem, and we have discussed about 5 types of subsystem, and the first one was altitude and orbit control subsystem. That is altitude and orbit control subsystem. So also known as AOCS. Here, this subsystem consists of a rocket motor, and this rocket motor is used to move the satellite back to the correct orbit. Whenever the satellite deviates from its original orbit or its path, this rocket motor, which is driven here, it consists of a rocket motor. That is, AOCS consists of a rocket motor. It moves the satellite back to the correct orbit, and this happens when an external force acts on the satellite. We have already discussed in previous class what are the external forces that is acting on the satellite, which causes the satellite to move from its original path or original orbit. So, in order to move back the satellite to the correct orbit, we have a rocket motors in this altitude and orbit control system. And this altitude and orbit control system must be controlled in such a way that the satellite antenna is correctly pointed towards the earth. Correctly pointed icon. Satellite antenna should be correctly pointed towards the earth station antenna. So, the altitude and orbit control system, it consists of a rocket motor to move the satellite back to the correct orbit whenever an external force acts on it and causes the satellite to move from its original path or deviate from its original path. And the satellite antenna should be correctly pointed towards the earth station antenna. This is the next thing which the altitude and orbit control system do. That is, it correctly points the satellite antenna towards the earth station antenna. And this is important for GEO satellite. This altitude and orbit control system is most important for GEO satellites. Means here in GEO satellite, the corresponding earth station antenna are fixed. That is, the GEO satellites corresponding earth station antenna are fixed. From GEO satellite in the antenna, variation there will be loss. This will cause loss of signal. There will be loss of signal. So, satellite antenna, that is GEO satellite antenna, the satellite antenna should correctly point towards the earth station, because the reason behind it is that the corresponding earth station antenna is fixed. So, correct transmission and reception and antenna face to face correctly pointed. So, this altitude and orbit control system, by using this altitude and orbit control system, this all are achieved. That is, satellite antenna is correctly pointed towards the station, and there will be no loss of signal. And as we have discussed, there are several forces acting on the satellite. There are gravitational, pull of sun, moon, solar pressure, and magnetic field. These are the various forces which is acting on the satellite. So this magnetic field, what it do is, whenever the satellite passes through this magnetic field, An eddy current is induced in the metallic structure of the satellite. And this so eddy current is induced in the metallic structure of the satellite. Whenever the satellite passes through the magnetic field which is created, so an eddy current is induced in the metallic structure of the satellite. This eddy current rotates the satellite, and this cause of rotation of satellite, or this rotates the satellite. So those are the external forces which is acting on the satellite, that is gravitational pull of sun, gravitational pull of moon, solar pressure from the sun, and magnetic field. And due to the magnetic field, eddy current is induced to the metallic structure and which rotate the satellite. So here the orbital control system should be able to move back the satellite to the equatorial plane. That is, this orbital control system must be able to move back the satellite to the equatorial plane before orbital inclination become excessive or orbital inclination become or increases. അതായത് orbital inclinations excessive ആകുന്നതിന് മുന്നേ അല്ലെങ്കിൽ increase ആകുന്നതിന് മുന്നേ the orbital control system must move back the satellite to the equatorial plane. അതിന്റെ റീസൺ എന്താണെന്നുള്ളത് നമുക്ക് പിന്നെ നോക്കാം. We'll study about that. So the orbital control system is responsible for moving back the satellite to the equatorial plane, and it should be moved back to the equatorial plane before the orbital inclination increases. So orbital correction must be done frequently so that so that the orbital inclination does not become excessive, or orbital inclination doesn't become or it doesn't increases. Orbital inclination കൂടാൻ പാടില്ല. Orbital inclination should not increase. This is about the attitude on orbit control system. We have discussed what are the reasons why we go for this attitude and orbit control system. This is because of the gravitational external force acting on the satellite, which causes the satellite to move from its original orbit or path. So we have now discussed why this is needed. That is attitude. What is attitude control system? Here we have two ways to control the satellite. That is, there are two ways which we can make the satellite stable in orbit. That is, we have two ways by which we can make the satellite stable in orbit if the satellite is weightless. In the case of weightless satellite, by using two ways, we can make the satellite stable in its orbit. The first way is the body of the satellite, that is weightless satellite, the body of the satellite is rotated at a rate of 30 to 100 rpm. That is, the body of the satellite is rotated at a rate of 30 to 100 rpm. So, by rotating this, that is by rotating the body of satellite, it creates a gyroscopic force. Gyroscopic force. And this gyroscopic force, it provides stability to the spin axis. And such satellites are known as spiners. That is, we can achieve satellite stability, or satellite is made stable in its orbit when it is weightless by rotating the body of satellite at a rate of 30 to 100 rpm. By rotating a satellite in this rate, it creates a gyroscopic force. This gyroscopic force, what it do is, it provides stability to the spin axis, and such satellites are known as spinners. By using spinner satellite, satellite stability is maintained in the orbit. And second is by using one or more momentum wheels. That is, by using one or more momentum wheels, we can achieve satellite stability. This is called three-axis stabilized satellite. This is called as three-axis stabilized satellite. This momentum wheel is nothing but usually solid metallic disc. And this metallic disc is driven by electric motor. So, satellite stability in orbit is achieved in two ways. That is, first way is the body of the satellite is rotated at a rate of 30 to 100 rpm. By rotating this at a rate of this, we can achieve a gyroscopic force. So, a gyroscopic force is created by rotating the satellite. So, this gyroscopic force provides stability to the spin axis, and such satellites are known as spinners. And next way to achieve stability is that one or more momentum wheel is applied, or by using one or more momentum wheel, and this is called three-axis stabilized satellite. And the momentum wheel is usually a solid metallic disc, and this solid metallic disc is driven by an electric motor. And as we have studied in attitude and orbit control system, we are using rocket motor. That is nothing but an electric motor. And there are basically two types of rocket motor. That is bipropellant or bipropellant thruster. And second one is jets or iron thruster. So these are the rocket motor, two types of rocket motor. This bipropellant thruster is a traditional one, and jets and iron thruster are the other type of rocket motor. And the fuel that is in GEO, satellite is used for two purposes. The satellite contains fuel. So the fuel in GEO satellites is used for two purposes. And the first purpose is to fire the apogee kick motor. And this we are firing the apogee kick motor so that the satellite is injected to the final orbit. That is, satellite is placed into the final orbit. So first we are placing in a transfer orbit. At the transfer orbit, at some point, this is our transfer orbit. So first we are placing our satellite in transfer orbit at the apogee point. At the apogee kick point, the motor gets fired. So fuel is needed for this firing purpose. So in order to place the satellite in final orbit from the transfer orbit at the apogee kick point or apogee point, we fire the motor so that the satellite is kicked off to the final orbit. That is from transfer orbit to final orbit. So fuel in GEO satellites is used for two purposes. That is to fire the apogee kick motor, that is to place the satellite from transfer orbit to final orbit. And second, the fuel is used to maintain satellite in that orbit. And second part of the fuel. First part of the fuel is used for firing the motor and kick out the satellite to the final orbit. And second part of the fuel is used for maintenance purpose of the satellite in the orbit for the lifetime. That is satellite lifetime where final orbit in the maintenance purpose second part of fuel use ചെയ്യുന്നത്. So fuel in geo satellite is used for two purposes. First one is to fire the epoxy kick motor, and second one is to maintain the satellite in that orbit for the lifetime. And next we will talk about, we have discussed about the attitude control system. Now we are going to learn about the orbit control system. So for an orbit to be truly geostationary, it should lie in that orbit must lie in the geo-equatorial plane. That is, geostationary is said to be the orbit which lies in the equatorial plane. So an orbit is said to be truly geostationary if the orbit lies in the equatorial plane. Equatorial plane orbit is geostationary orbit. So for an orbit to be truly geostationary, it should lie in the equatorial plane, and it should be circular and should have correct attitude. So the various force acting on the satellite, that is, will pull out it from the correct orbit. That is, the satellite in the model acting in the various forces. Satellite is pulled out from the correct orbit. This satellite from the correct orbit is pulled out by the various external forces. So it is the function. So it is the function of the orbit control system to return it to the correct orbit. So by using this orbit control system, we can return the satellite to the correct orbit, and this can be done with gas jet. And it cannot be done with this momentum wheel, since we here require a linear acceleration. So a linear acceleration is required. So we cannot use momentum wheels, which we have used in attitude control system. So here we use a gas jet. This impart a velocity. This gas jet impart a velocity along the three reference axes. So for the orbital corrections, we use gas jet, and this gas jet, what it do is it impart a velocity along the three reference axes. We cannot use momentum wheel here, since here we require linear acceleration. So by using momentum wheel, we cannot achieve linear acceleration. So instead of momentum wheel, we use gas jet for orbit control subsystem. And this gas jet impart velocity along the three reference axes of the satellite. And correcting the inclination of the satellite require more fuel. That is, orbital inclination correction we require more fuel. Orbital inclination correction require more fuel than orbital correction. That is, orbital inclination correction require more fuel than orbital correction. So we have mentioned earlier that orbital inclination should not become excessive. Orbital inclination excessive fuel requirement increases. So orbital inclination. So before orbital inclination become excessive, we have to do the orbital correction. So orbital inclination depend upon orbital correction. As orbital correction or orbital inclination require more fuel than orbital correction, we should take care of orbital correction. So if orbital inclination increases, it requires more fuel for orbital inclination correction. The orbital correction the rate കുറഞ്ഞാൽ orbital inclination become excessive ആകുന്ന സമയത്ത് requirement of fuel also increases. So communication payload decreases or reduces. ഒരു സാറ്റലൈറ്റിന് ക്യാരി ചെയ്യാൻ പറ്റുന്ന വെയിറ്റ് ഉണ്ട്. ആ വെയിറ്റിനെല്ലാം ബാലൻസ് ചെയ്തിട്ടാണ് സാറ്റലൈറ്റ് നമ്മൾ ലോഞ്ച് ചെയ്യുന്നത്. സോ കമ്മ്യൂണിക്കേഷൻ പേലോഡിന് ഇത്ര വെയിറ്റ്. അപ്പം നമുക്ക് ഈ ഫ്യൂവല് കൂടുന്നതിനനുസരിച്ചിട്ട് നമ്മൾ കമ്മ്യൂണിക്കേഷൻ പേലോഡിന്റെ ലോഡ് കുറക്കണം. അതായത് കമ്മ്യൂണിക്കേഷൻ എക്യുപ്മെന്റ്സിന്റെ വെയിറ്റ് നമ്മൾ കുറയും. സോ കമ്മ്യൂണിക്കേഷൻ പർപ്പസിന് നമ്മൾ സെൻഡ് ചെയ്യുന്ന എക്യുപ്മെന്റ്സിനനുസരിച്ചിട്ട് എല്ലാ എക്യുപ്മെന്റ്സിന്റെ വെയിറ്റ് കുറക്കേണ്ടി വരും. നമ്മൾ ഫ്യൂവൽ കൂടുന്നതിനനുസരിച്ച്. ഫ്യൂവൽ കൂടുന്ന ആവശ്യം എന്ന് വെച്ചാൽ ഓർബിറ്റൽ ഇൻക്ലിനേഷൻ കറക്ഷൻ ആണ് ഫ്യൂവൽ കൂടേണ്ട ആവശ്യം. സോ it reduces on orbital inclination excessive on the samayathu fuel requirement കൂടും and the communication payload also reduces. Communication payload the satellite can carry. The satellite can carry. So the communication payload the satellite can carry also reduces depending upon the orbital inclination correction. And other than this geo orbit, LEO and MEO orbit, that is low Earth orbit and medium Earth orbit, also require or also need this AOC system to maintain the correct orbit. So we have already said that this AOC system is most important for the geo orbit. So other than this geo orbit, LEO and MEO also need AOC system to maintain the correct orbit and for continuous communication. So this is about the attitude and orbit control system. We have discussed about the attitude control system. We have also discussed about the orbit control system. And in altogether, this is needed for the correction, orbital correction and orbital inclination correction. Now we are going to discuss about the second subsystem, that is telemetry, tracking, command and monitoring. Telemetry, tracking, command and monitoring is also known as TTCNM. So talking about this subsystem, this is partly on satellite and it is other part is on the Earth. Earth station. So this telemetry is partly on satellite and it is partly on the Earth station. And this TTCNM system is essential for the successful operation of a communication satellite. And it is a part of satellite management. It is a part of satellite management. And the main function of the satellite management are to control the orbit and attitude of the satellite. So the satellite management, what it do is it control the orbit. We have discussed in AOC, it control the orbit and attitude. It control the orbit control and attitude control. So satellite management, the main function is to control the orbit and attitude of the satellite and monitor the status of, also monitor the status of sensors. Usually 100 of sensors are used in satellite. So it monitor the status of satellite sensors and the subsystem on the satellite and switch on and off communication system. These are the functions of the satellite management. So they're talking about the TTCNM. It's partly on satellite and partly on Earth station. കുറച്ച് പാട്ട് സാറ്റലൈറ്റിലും കുറച്ച് പാട്ട് എർത്ത് സ്റ്റേഷനിലാണുള്ളത്. And the satellite management is also known as satellite management, or the function, its function is also satellite management. And first function of satellite management is orbit control and attitude control. Next is it monitor the status of sensor. It monitor the status of sensor. And third point is switch and on and off of communication system. And talking about the first part, which is telemetry and monitoring. Telemetry and monitoring. This monitoring system, what it do is it collect data from all sensors in the satellite. It collect data from all sensors in the satellite. That is, this monitoring system, what it do is it collect data from all sensors within a satellite and sends the data to the controlling Earth station. And it sends data to controlling Earth station. So this monitoring system, what it do is it collect data from all sensors in the satellite and sends the data, collected data, to the controlling Earth station. There are several hundreds of sensors that are placed within the satellite to monitor the pressure in the fuel tank, and that is, the sensors are placed in the satellite to monitor pressure in the fuel tank and to monitor the voltage and current. To monitor the voltage and current in what? Power unit. For power conditioning unit, voltage and current in a measurement, current in a monitoring. Or to find the critical voltage and current in the communication electronics. So what this monitoring equipment do is monitor the data, or it collect the data from all sensors in the satellite and it sends the data to the controlling Earth station. So here there are hundreds of sensors placed in the satellite, and some of the functions of the sensors are it monitor the pressure inside the fuel tank, it monitor the voltage and current inside the power unit, and it also monitor the critical voltage and current in the communication electronics. And some sensors are used for temperatures, that is, temperature sensors are used, and temperature of many subsystems is important, and it must be kept within a predetermined temperature. Sensors use it. The temperature of many subsystems are kept in predetermined level. That's predetermined level. So many temperature sensors are fitted for this purpose. And the sensor data, the status of each subsystem and the position of switches in the communication system are reported back to the Earth by telemetry. So here comes the purpose of telemetry. So the sensor data, that is the monitor system, collect the data from the sensor. So sensor data is sent to the Earth station. The satellite in the sensor information. Satellite sensor information is given or transmitted to the Earth station via a telemetric link. So telemetric data are usually or telemetric link is usually for transmitting the sensor information from the satellite or transmitting the information about the satellite to the Earth station. So telemetric data are usually digitized, and this transmitted as PSK, the phase shift keying using time division technique. So, monitoring system, what it do is it collect the data from the sensors, and the telemetry, what it do is it sends the censored data to the Earth station via telemetric link. The telemetry informations are usually transmitted as digitized data, and it is transmitted as PSK, that is phase shift gain, by using time division technique. At the controlling station, now at the control station, that is at the controlling station, we have a computer, and this computer is used to store, decode, and monitor the status of sensor. Here, in the controlling Earth station, we have a computer. This computer is used to store, decode, and monitor the status of the sensor. And we have an alarm. This alarm can be also sounded. The alarms get sounded if anything or any parameter goes outside the allowable limit, or anything, if anything goes wrong, this alarm also gets sounded. So this is about the telemetry and monitoring. Now we are going to the next part, which is tracking. That is tracking. Here we have a number of techniques to determine the current orbit satellite. That is, to determine the current orbit of a satellite. That satellite or orbit correct to determine the current orbit of a satellite. Satellite orbit we have a number of techniques. So, velocity and acceleration sensors on the satellite. The velocity and acceleration sensors on the satellite are used to establish change in orbit from last known point. So, tracking, a number of techniques can be used to determine the current orbit of a satellite. Satellite in the current orbit, we have a number of techniques, and velocity and acceleration sensor on satellite can be used to establish a change in orbit from the last known position by analyzing the data. The velocity and acceleration sensors in the data analyze it, we can find out the change in orbit position from the last known point. Last the point point in the change the information we get from velocity and acceleration sensors analyze it. So tracking can be done with the help of velocity and acceleration sensors. Here, active determination of range can be determined. That is, range can be determined by transmitting, we have already discussed, by transmitting pulses or sequence of pulses. The range can be determined by transmitting pulses or sequence of pulses, and by observing the time delay or propagation delay, we can determine the range. Range it can be determined by transmitting pulse or sequence of pulse from satellite and observing the time delay. Satellite in the Earth station information a pulse time delay measure we get the range information. Here, more than one earth station take the measurement of range. Range measurement is more than one earth station performing. That is, more than one earth station may take range measurement with an adequate separation in observing the satellite. So here for range measurement, ranging tones are also used. Ranging tones are also used for this range measurement. Next is the command which you will study in next class.